In this video, I'm going to take a look at evaluating this integral of 6x squared divided by the square root of 3 plus 2x to the third dx. So on the surface, this problem looks pretty intimidating. It looks pretty scary with all the x's, x to the second, x to the third, square roots, the radicals on the bottom. Looks pretty intimidating. But when we just start to think about substitution, what a very good substitution to make, or at least try, would be what's inside the radical. So what we want is we want to set that equal to u, take the derivative, and then hope that that derivative works out in our favor to help us out with this term here, 6x squared. That's what we want. That's what we're shooting for right now. So let's set u equal to 3 plus 2x to the third. And then take the derivative. So du equals the derivative of 3 is 0. And then the derivative of 2x to the third is going to be 6x squared dx. Look at that. 6x squared dx, 6x squared dx. Nice. We have an easy substitution that helped us out completely. We don't have to offset anything. We don't have to worry about any lingering constants. It all substitutes out. So here's how we're going to make this substitution. I'm going to have 1 over, so what I did is I changed this to u. I changed this inside statement to u. So that's going to be u to the 1/2. And I'm trying to save some steps here, but that's square root of u, that's just u to the 1/2. Because I have that u statement underneath the radical, I'm just changing that to 1/2. And then we have du, because I'm taking out 6x squared dx for du. And you can write this as du over u to the 1/2. It doesn't matter, but I'm just going to leave it like that. And then now we just have an integral to perform. So let me erase all this. I don't want to get too messy here. So now we just have to integrate this. So let's go ahead and do that. So I'm going to, in order to integrate this, I'm going to bring the u up. So it's u to the negative 1/2 du. And then we have to add 1. So add 1. So this is me negative 1/2 plus 1. So over 2, negative 1/2 plus 2 over 2 is going to be u to the 1/2. Which means we're going to have divided by 1/2 because it's just that exponent. And we can clean this up a little bit. So it's going to be 2u to the 1/2, because if we're dividing by 1/2, we're really multiplying by 2. Plus c. Got to make sure we put back in our original u, what we decided u was. So that's going to be 2 times let's just put this in the radical. So I'm replacing u with my u. What is u equal to? U is equal to 3 plus 2x to the third. And that was the 1/2, so that's why I'm throwing it underneath the radical. You could just write this as 2. And then 3 plus 2x to the third to the 1/2 plus c. That's also fine. But that's why I just converted it back to the radical form there. And that would be our answer. Yeah, so tough integral on the surface. I think just when you look at that, it looks a little bit intimidating, but if you're getting good with substitution, you're getting used to the process, and things hopefully work out. And in some cases, this isn't going to work out as nicely as it did, but in this case, it did. So you got to go with it when we get lucky, and the substitution just works in our favor. So good luck.